Hello, fellow mathematicians. You are back with Miss Ledbetter, and it is time to do some more math. So today we are going to be talking about function compositions. So we talked about our function notation, we've talked about function operations. Now we're going to do some function composition, meaning that we are going to be composing a new function out of two other already existing functions. So function compositions, taking two and making them to become one. This is going to be recorded in your notes, in your interactive notebook on page 6. So make sure that you are recording these notes in your notebook. Again, you will have a quiz tomorrow in class. So you will be able to use your notes. Make sure you're taking diligent notes. Okay, so before we actually do any compositions ourselves, let's figure out, well, what in the world are we talking about when we say composition of functions? So here is the key concept. This is the understanding or the rule to find the composition of functions. So the composition of function g with function f is written as g with an open dot circle f, and that's read as g of f. And so you would see it written as, in the parentheses, g of f of x. Well, that's exactly the same thing as taking the f of x function and putting and embedding that into the g of x function. So in other words, I'm taking the f of x function, the entire function itself becomes the input of the g of x function. So I'm taking all of the f rule and putting it into the g rule, just as if I had an actual number or a value that I would be substituting using the function notation. It's the same idea, only now we're taking all of an entire function in itself, the whole equation. Okay, so it says that first thing we're going to do is we first have to evaluate the f of x, because that's what comes second in the rule, g of f. So we're going to figure out what is the f of x function, evaluate that first. Then we're going to use whatever answer we get from that as the input value for the g function. Okay, so let's look at a couple of examples here. Okay, so let's say that we have two functions, f of x is x minus 5, and g of x is x squared. So then let's say we wanted to find f of g of negative 3, okay? So really that's the exact same thing as saying that I'm going to first, because the g of x comes second, that's going to be the one that I'm going to evaluate first. I'm going to work from the inside and work my way out. So that is the same thing as saying that I'm taking all of g of negative 3 and then putting that value into the f function, okay? So g of x becomes embedded in the f of x function. That's where it becomes a composition. I'm taking two functions and creating one function altogether. So first I have to evaluate what is g of negative 3. Well, because g of x is x squared, that means I'm going to take negative 3 squared, which we know negative 3 squared is 9. So that means 9 is now the input that I'm going to use in my f of x function, which is x minus 5. So then substitute 9, I get 9 minus 5, which is 4. So therefore, final answer for the composition function for f of g of negative 3 equals 4. It is a final output of 4. Okay? So then let's do another example. What if we did, instead of f of g, what if we did g of f? Okay, so there's a difference here. Now the g is first and f is our second function. So that means I'm going to first evaluate my f of negative 3 function, take that answer and put that into the g function. Okay, so basically I'm doing the opposite of what I just did with the f of g. Now I'm doing g of f, different order. So first evaluate f of negative 3. Since f of x is x minus 5, that means I'm going to take negative 3 minus 5, substituting negative 3 for x. Well, negative 3 minus 5 is negative 8. And because g of x equals x squared, I'm going to move over here so you can see it, then I'm going to take negative 8 squared, which is a positive 64. So g of f of negative 3 equals 64, whereas our f of g of negative 3 equals 4. So notice in the key concept box, the very last statement says that function composition is not commutative, meaning that you cannot go both directions, like adding and multiplying. Order doesn't necessarily matter. It is not commutative since f of g of x does not always equal g of f of x. So that's going to be very important when we talk about inverse functions later on this week. So notice that g of f and f of x are not, or f of g are not the exact same thing. They're not going to give you answers. So order is very important. So make sure that you work from the inside out. Okay? So then what if I wanted to not evaluate the function given a specific input? What if I just wanted to figure out what is the composition function in terms of x? So for example, what if I wanted to use these two functions and find the value for p of q of x? So this time they're not giving me an actual number that I'm going to substitute, so that means my answer is going to stay in terms of x. That means I'm going to have an x somewhere in this equation still when I get to my final answer. So my answer is not going to be just a single number. It's going to have a variable within it somewhere. Okay? But again, still the same thing. If I rewrite it, because p comes first, that's going to be my outside function, and then the q of x is second, so that's going to be embedded into the p of x function. So that means I'm going to take all of q of x, which is 4x plus 1, and put all of that into the p of x function. So now in the p of x, x in that equation now becomes 4x plus 1. So whereas the p of x function is 3x minus 2, now becomes 3 times all of 4x plus 1, and then the minus 2. So notice how the only thing that changed from the original p of x equation is now x has been replaced with the q of x function, which is 4x plus 1. Okay? Then from there, actually do the math and simplify as much as we can. So because of the 3 sitting in front of the parentheses, I know I need to do distributive property. So 3 times 4x gives me 12x. 3 times 1 gives me 3. And then the minus 2 is just still hanging out there outside of the parentheses. Then combine like terms. Unfortunately, 12x doesn't have another x value to be combined with. So therefore, 12x just stays by himself, 12x. He doesn't have any friends to play with. And then plus 3 minus 2 becomes a plus 1. So the value for p of q of x is 12x plus 1. Notice how I still have x in my answer because I wasn't given a specific input value. Okay? So now let's do that again, exactly the same equations, but this time let's find q of p, again, different order. So because q of x comes first, that's going to be the last thing that I'm going to do. I know it sounds weird, it's backwards. P of x is my second function, so that means that's what I need to evaluate first. So the first thing I'm going to do is figure out what is the p of x equation, take that whole thing plugged into the q of x function. So because p of x is 3x minus 2, then I'm going to substitute the 3x minus 2 in place of x on the q function. So q function is 4x plus 1 now becomes 4 times px, which is 3x minus 2, and then the plus 1. All right, so we're just plugging in and substituting just as if it was a regular number. And then again, simplify, do what you can to actually make it as simple as possible. So therefore, again, distributive property. So 4 times 3x is still 12x, and then 4 times a negative 8 is, or negative 2 is negative 8, and then the plus 1 is still just kind of hanging out because he wasn't part of the distributive property since the parentheses stopped there. Then combine like terms, again, 12x still doesn't have any friends to play with, so he's just going to stay 12x, and then minus 8 plus 1 becomes minus 7. So final answer for q of p of x is 12x minus 7, whereas p of q, if you go back and look, was 12x plus 1. Not exactly the same thing. They still had the 12x, but it's not always going to work that way. So if it asks for both functions to go p of q and q of p, you actually do have to work out both of them because you're not going to get the same answers twice. Okay? Okay, now it's your turn. So here are two functions, f of x equals 3x minus 5, g of x equals x squared plus 2, and here are 3 practice problems for you to work on your own. So at this point, I need you to pause the video, take some time, so see if you could work out some of these problems on your own and see if you can come up with the correct answer. Once you have your answers, then click back on the video to play and see if you can check your answers to make sure that you got everything right. So take a few seconds and see if you can figure out these problems. Okay, hopefully you've given yourself some time to actually work these out. So for the f of g of 2, so that means I'm going to substitute the value for 2, start with g, get the answer, then plug it into f, should give you 13 as your final answer. G of f of 2, starting with the f function, you plug in the 2, get that answer, then go to the g, should give you a value of 3. Notice how they're not the same thing. Okay, be careful with that. And then the f of g of x, so if I'm not substituting a number, leaving it in terms of x, should give you 3x squared plus 1 once you simplify it. Hopefully you were able to be successful on those. If not, go back, rewind, look at some of the video again, see if you can figure out why you missed, what you missed, and then we can talk about it tomorrow in class together if you still have questions. Okay? So thank you so much for watching this video. Like I said, if you have questions, come see me, come talk to me, and we will get you straightened out. And I will see you next time.